Hello, welcome everybody. Bom dia a todos. É um prazer estar com vocês. Thank you guys. Nice to see you again here in our event. We've been together for almost a year and we're reaching to the highest point, which is going to be in August 23rd this year, finally, okay? And on top of that, August 23rd is going to be my birthday. Wow, that's so special. It took so long and they picked the right date after all. So thank you everybody for coming here, okay? So welcome to our July's International Webinar. 10 reasons why our relationship with groundwater is a total mess and what should be done about it. That's a great name and it is a great talk and we'll have a great debate about that as well. So welcome everybody. Adding to the free session of this first part of the Groundwater Congress, which is a joint achievement of IAH, ALSUD, and ABAS, the Brazilian Groundwater Association. We started with 8 sessions in September, and after 21 webinars, yes, 21 webinars, wow, we reached more than 20,000 views. If you have missed them, please add to the numbers and access ABAS on our YouTube channel, okay? We remind you that we will offer 2 sessions per month until August, which is next month, as I told you, when we will host the presential part of our event. 1 session, oh, it's not gonna be presential, it's going to be virtual. We had to change that and we forgot to change that in my presentation text here, sorry guys. 1 session, more market related and the other scientific. Please follow ABAS, IAH and ALSUD on our social media to stay informed. We have more than 900 participants on 10 thematic WhatsApp groups, and our app has been downloaded by more than 400 participants. Also, on February 1st, we launched the online edition of FENAGUA, our National Water Trade Show, with more than 200 exhibitors. You can access it by visiting the event website www.iah2021brazil.org. These always growing numbers are a proof of the successful digital strategy to create the world's largest groundwater community. Welcome to join us in this largest community. We would like to thank our sponsors, supports, and expositors who allow this great event to take place. Sponsors: ANA, Agência Nacional de Águas e Saneamento Básico no Brasil. Vale, the support of CBHSF, Comitê da Bacia Hidrográfica do Rio São Francisco, Peixe Vivo Agency. Exhibitors: Altri, Bodega do Poço, Chicago Numeric, Ebara, LG, Maxiagua, The Groundwater Project, CRI Bombas, Lepono, Aragon Sondagens, Clean Environment, Franklin Electric, Paze Hidrometria, Perfuratrizes DTH, AGB Peixe Vivo, ALS, Brain, Eurofins, G Hidro Monitoramento, GLP Laboratórios, Hexis, In Situ do Brasil, PRD Rigs, Trionic, Vapor Solutions in Water Services and Technologies. Thanks for everybody for supporting us. This is so important. We'll have 3 presentations today, followed by a roundtable where the viewers can participate by sending questions to the speakers. The questions may be sent by our app. Please download it on your preferred Jesus today. And it's not 7:30 as it is for Dave Kreamer. I should be awake already. Okay, please download at your preferred app store. Just search for IAH 2021 or directly on your YouTube chat. This session has simultaneous translations into Portuguese also on YouTube. Please make sure you direct your questions to one of our guests. Okay, thank you very much. This session will be hosted by me, Everton de Oliveira, the president of the 47th IAH Congress Organizing Committee. And our guest speakers are John Cherry from the Groundwater Project, that doesn't need more introduction, I guess. Dave Kreamer, similarly, president of the International Association of Hydrogeologists and professor at the University of Nevada. And Ricardo Andrade, a former director and now advisor of institutional relations to the National Water and Sanitation Agency, ANA. Okay, now I'll introduce you our first guest, Dr. John Cherry. I'll be short. John is author of the famous book, Freeze and Cherry. If you're participating on this event and you don't know this book, what the hell are you doing here, man? You should go and read it. Don't miss out. And now we have this book in many other languages. Go for it, please. He is also the recipient of the 2020 Nobel of Water, Stockholm Water Prize. He is the head of the Groundwater Project, which I'm happy to participate with. And he's professor at the University of Guelph, former professor at the University of Waterloo in Canada, among many other important achievements. Thank you. John, the stage is yours. Please, welcome.
Am I on now?
Yes.
Well, thanks, Everton, for that nice introduction. It's always a pleasure to hear you speak and talk about this grand IH meeting. So I'll give a talk that I've been working on now for quite a number of years. So if we can have the first slide, please. And it's my great pleasure to be able to speak on this topic to you. So as Everton mentioned, I received the Stockholm Water Prize in 2020. But 4 years before that, I received the Asian equivalent of that prize, which is the Lee Kuan Yew Prize out of Singapore. And when I arrived in Singapore, thinking that I would talk about my research, etc., I found out that very few people in the grander world of water are interested in groundwater. And I realized very quickly that I needed to think of ways of speaking to people that not only don't know anything about groundwater, but which aren't inherently interested. And so this talk has grown out of this role that I'm now playing at trying to speak for groundwater in the world water community. Next slide, please. Next slide, please. And in the preparation of this talk, I've had many good collaborators. I think as you'll see as we go along, there are various ways of looking at this topic, and collaboration and communication is important to getting it sorted out. Next slide. So I was asked questions, on the media, on CNN Asia, etc. Like, where's groundwater? Why is groundwater important? What are groundwater problems? Are the problems important? Who are impacted? And what is the future for groundwater? And most important of all, is groundwater in a global scale crisis? Next slide. And my conclusion then is our relationship with groundwater is a total mess. Some people don't like that topic, and sometimes when I talk about it, I say it's broken or it's unsustainable. But no matter how you look at it, we've got a big problem. Next slide. An important caveat on this is that although our relationship with groundwater is a total mess, groundwater, nevertheless, is an essential water resource, is not yet a total mess. Many aquifers are not depleted, and most groundwater is still safe to drink. But the point is that the global trend is alarming. Next slide. And a committee in Europe established this diagram listing all the ways in which groundwater provides a service to humanity and ecosystems. It provides domestic water, irrigation water, industrial water. It buffers wet and dry periods. It buffers against climate change. It feeds springs, base flow, etc. So groundwater provides many services of which outside of the groundwater community, very few people recognize. Next slide. For example, we see pretty pictures like this in National Geographic magazines. And everybody is concerned about animals, World Wildlife Fund, etc. But nobody, when they look at pictures like this, realizes that they're looking at the animals being sustained by groundwater seepage. Next slide, please. Now, there's a new environmental movie on Netflix based on a paper by Johan Rockström, which everybody should look at. And this production was led by Sir David Attenborough, who does so many environmental movies on television. The film is focused on the work of renowned Swedish climate scientist, Professor Johan Rockström, on tipping points that the world must not exceed if we are to protect humanity against disaster. But groundwater is not mentioned. Next slide. And this is the famous diagram from Rockström's paper in Nature. He's got 9 boundaries, of which he says 3 were beyond safety, one of which is climate, and another which is biodiversity, etc. And the statement is, if these boundaries are transgressed, then human sustainability on the planet is in jeopardy. Now, this is a very important paper because it tells us that we must pay attention to more than just climate change. So this paper and what he proposes as his framework is a new paradigm. Next slide. So according to Rockström and his colleagues, there are 3 boundaries already transgressed of the 9: climate, biodiversity, and the nitrogen cycle, but not the freshwater boundary. So we should ask the question, is this a reasonable conclusion? We in the groundwater community, because this is a very influential documentary film and paper in terms of the global readership. So in a groundwater perspective, groundwater is a key to the freshwater boundary. Groundwater makes up 99% of all liquid freshwater on planet Earth, provides 50% of river flow, provides drinking water for about 50% of the world population. Groundwater supports 40% of global agriculture and 70% of all irrigated agriculture. Next slide. So we're on a disastrous trajectory from humanity concerning fresh water. And this is not my conclusion. These conclusions are published. 4 billion people live in areas that suffer from severe physical water scarcity for at least 1 month per year. And that map on the right shows all those areas in in red and yellow, where the water is scarce. Groundwater use is projected to increase by 30% by 2050. Of course, that can't happen because there's not enough water to allow this to happen in most places. More than 2 billion people have no access to safe drinking water, according to HUE and UNICEF. Disappearing groundwater resources may act as a trigger for violent conflicts and have the potential to generate waves of climate refugees. And in fact, the Syrian civil war is partly attributed to a drought. Next slide. So questions. Why is groundwater a total mess? And is there a global freshwater use crisis? And if so, what is groundwater's role? And is Rockstrom correct? Next slide. So evidence for the mess. We have land subsidence, empty reservoirs during droughts. We have people who are unhealthy because of drinking water with too much fluorine or arsenic. We have overpumping for irrigation. We have intensive use of water for factory animal farms. We have seawater intrusion, and we have salty soil and more. Next slide. So there are 3 parts of the problem, the way I'm framing it. You've got depletion, salinization, and water quality. Next slide. So for depletion, 1/3 of the world's major aquifers are irreversibly depleted. That means that they wouldn't be filled up again with recharge if we stopped all pumping now, except over many decades or longer. And this shows one of the largest aquifers in the world, the Ogala Aquifer in the Midwest United States, which is a food basket for many people. Next slide. And then there's groundwater mining. And on the left, we see a bunch of green dots, and those are where crops are being grown with irrigation. But the irrigation is being done with fossil water. And fossil water wells are supplying hundreds of millions of people globally. And there's nowhere in the world that's more water dependent, of course, than the Arabic region. Next slide. We've got highly publicized recent droughts, but these highly publicized droughts that we know so much about from our newspapers and media are of short duration, just a few years. Next slide. This is a complicated graph. The upper graph with the data on it is some work that colleagues and I did a few years ago and published, and it's an indicator of recharge over the past 500 years at a site in Southern California. And the lower graph is a correlation with it coming from tree ring evidence. But the only thing here is the blue represents the wet periods, the yellow represents the dry periods. And if you look at the most recent drought in California, that's just a few years. So even without climate change, if we look at the past historical record of climate and relating that to groundwater, we've had severe droughts, and severe droughts are coming at us for sure. It's just a matter of when they'll hit and where they'll hit. Next slide. Even Canada is having drought now, but totally unprepared. This is a big surprise. It's a big crisis. Every drill rig within 1,000 miles or 1,000 kilometers is arriving in these red areas then to drill wells. We Canadians think we have unlimited water, and that's what we learn as school children and whatnot. But droughts, when they hit, as they did back in the 1930s, can be devastating for parts of our country. Next slide. So we're depleting water from aquifers, and we're depressurizing aquitars to cause land subsidence in many areas. Next slide. Now on the right, here we have a statement. Groundwater pumping in excessive recharge contributes to 25% of mean sea level rise. Okay, whenever you read about sea level, it's all about climate change, and it's all about glaciers melting, etc. But according to Wood and Dave Heitman at Michigan, if you crunch the numbers, all this excess groundwater being pumped that's depleting aquifers is actually contributing 1/4 of sea level rise. Who would ever know that except a person who might read an editorial in Groundwater? And when you take subsidence, then groundwater is the largest cause of relative sea level rise at many coastal cities. It's a combination of land subsidence and groundwater depletion. People think it's all about climate change. No, for those cities, it's all about groundwater. Next slide. 3 parts of the problem. Let's look at salinization. Next slide. And we get seawater intrusion in many coastal areas around the world. And when you're sitting at your big hotel in Bali the next time, drinking your cocktail, you probably should keep in mind that while you drink, then there's seawater intrusion going on, because most of these hotels in many developing countries then are pumping away too much groundwater. And Bali, for example, has a huge groundwater salinization problem, basically brought on by the tourist industry, which is their main feed for employment. Next slide. Irrigated agriculture salinizes soil, a chronic problem. Progressive aquifer salinization of groundwater recharge by irrigation return flows occurring in many semi-arid regions. So we're losing arable soil because of the way groundwater is used. Next slide. And the oil and gas industry releases saline waters. So just about anywhere where there's an oil well or anything to do with oil exploration, there tends to be saline water discharges, because part of what comes up from deep down is salty water. Next slide. Okay, and then there's a water quality problem. And the first part of this then will be natural, or geogenic as it's called. Next slide. So we have harmful geogenic constituents. Geogenic being basically from the geology: arsenic, fluoride, manganese, uranium, and radium. And overall, hundreds of millions of people drink water with one or more of these, but health effects generally are not assessed. So we don't know how big this problem is. Next slide. If we look at arsenic, okay, this is a map across the globe where arsenic was a problem. Okay, but this is based on the previous drinking water limit for arsenic, which is 50. And the drinking water limit was lowered in the US and around the world in 2001. So once you lower the drinking water limit from 50 to 10, that puts millions and millions of more people actually in the jeopardy part of the arsenic problem. Next slide. And these numbers are phenomenal. Proportion of globally affected area: Asia, 64%. And within that affected area, then about 90% of the population are affected. South America, 14%, North America, et cetera, et cetera. So geogenic arsenic, and if you add in all the other compounds that are harmful, like radium and fluoride, uranium, et cetera, then you have quite the numbers. Most of this not yet having been assessed. Next slide. According to an expert on this topic, Yan Jing at SUSTEC in China, the population affected by groundwater arsenic from domestic well supplies has been frequently stated to exceed 100 million. However, the compilation is fraught with uncertainties due to unreliable records of domestic wells that supply drinking water. And these records are unreliable in the United States and Canada and just about everywhere because of the lack of detailed monitoring and study of private wells and small village wells and small town wells. Okay, continuing then in the water quality domain, we've got pollution. Next slide. And this little schematic then shows some of the ways in which groundwater becomes polluted: septic tanks and mining and animal sewage and fertilizer, et cetera. Many different ways. And this has been going on for many decades. Next slide. And if we look at all the ways in which contaminants get into the ground, and this is a list of more than a dozen. So there are hundreds of millions of locations across the globe then where contaminants are going into the ground, because in many cases the water table is only a few meters down. So things easily go into the ground if we operate in a way that allows such releases. Next slide. Now on the left, we've got a diagram here that shows the history of groundwater contamination. It started off in the 1950s with heating oil organics and chromium, and then road salt and nitrate, and then leachate and pesticides, et cetera. And then we work our way up into the modern period when we get to 1,4-dioxane and pharmaceuticals, et cetera. And now we've got PFAS and maybe nanoparticles and others. So all this has been developing over the last 70 years. But the problem with groundwater contamination is that it's cumulative, and it takes a long time for flush out, decades or centuries, because of back diffusion from low permeability zones. Conversely, though, contamination in rivers and air is temporary, quickly flushed out. So when you stop putting things in the atmosphere, you can quickly see it with the air quality improving. The same with rivers. Next slide. So aquifers with no detectable contaminants are rare. There's little pristine groundwater remains. That doesn't mean all this water is affecting you in any way. We're just talking about the contaminants being there. And the number of different types of chemicals in groundwater is increasing and plumes are expanding. And I'm not arguing here that we're all going to die from any of this. What I'm arguing is we're not monitoring it and we don't know the size of the problem. So groundwater gets ignored. Next slide. There's a term called assimilative capacity, which engineers rely on. its ability of pollutants to be incorporated into an environment without unacceptable detrimental effects. Next slide. And the purpose of determining the assimilative capacity is to find out the degree of use of a natural system that is consistent with preserving the integrity and health of that natural system. So engineers use assimilation capacity all the time when they build a sewage treatment plant, and when you put air treatment on your factories. All of that is based on assimilation capacity. We know that we can only release so much into the air and into the rivers without causing harm. Next slide. But when talking about assimilative capacity, we can model it when it comes to surface waters and air, but not model it or even understand it quantitatively when it comes to groundwater. So that's a big disadvantage for groundwater, and one of the reasons why we have to stop putting chemicals into groundwater. Next slide. So agriculture is the biggest groundwater polluter with nitrates and pesticides. And the Green Revolution, which was intended to lift poverty into an area where we wouldn't have to worry about food supply, was a dirty revolution for groundwater, and it was a failure even in terms of providing food. Next slide. Now, if we look at nitrate, so much excess nitrogen is used for fertilizer that 16% of the total estimated global continental nitrogen budget is due to nitrate fertilizer overloading. It'll take decades to flush this out. And colleague Warren Wood has submitted a paper about this. So all of this nitrogen that's said to be a crisis, then groundwater is a major part of it. Next slide. Now, fertilizer nitrate causes immense contamination, but not so for pesticides in most developed countries. I'm not arguing here that pesticides don't cause contamination, but they're not anywhere near the magnitude of the problem of many other things. And this is because there are specific regulations for assessing pesticide environmental impacts before approval of use. And no such regulations exist for any other types of chemicals. So we can talk about pesticides, but at least we know a lot about them. Next slide. And the most recent surprise, all of these types of contamination that hit us after decades come as a surprise because we're unprepared. PFAS may be the worst contaminant of them all because it's mobile, not degraded, very toxic. It bioaccumulates, and analyses are difficult. Next slide. And a few days ago in The Guardian, Maine is the world's first government to enact a broad prohibition on a class of about 9,000 compounds, PFAS, which are dubbed forever chemicals. So it's a good news, good move, but Maine is the first place to do it, and it comes 30 years too late. Next slide. And water is in food, and it's referred to as virtual water. Okay, and so you may think that you're not sitting where there's a groundwater problem, but the food you're eating may be unsustainable groundwater, and therefore it won't be supplied in the future. And the countries from which this unsustainable groundwater is being produced may be suffering. So globalization has been bad for groundwater in general because it hasn't been part of what people look at. Next slide. And let's take this recent article. This article focuses on Peru, where agricultural export production has led to huge economic growth and employment, but at the expense of unsustainable aquifer depletion. So these good things of economic growth and employment are going to come to an end. Next slide. There are two categories of groundwater problems around the globe. There's too much depletion and pollution, mostly in the rich countries, and regions where there is a desperate need for more pumping wells, but the needed wells have not yet been drilled due to poverty and poor governance. So in some cases, we have too much. In other cases, we have too little when it comes to groundwater use. Next slide. And I've made many trips into the countryside, into the mountains in Mexico and China and other places, and it's not uncommon to see a school that is in bad shape because they don't have a well. Building a school can be easy, but often providing a safe water supply for the school is not. Lots of aid groups build schools and get a lot of credit for that, but nobody seems to include the well as part of the basic need. Next slide. So all groundwater problems are local to a farmer, a town, a city, a province, or state. So on what basis can we say that there's an impending global groundwater crisis? Well, when these local problems are frequent enough and distributed enough to impact a large enough number of people in enough countries. Maybe that would be the answer. Next slide. And here I have some hypothetical graphs. On the left, I've got a graph of population impacted versus time, and the graph goes up and it hits a threshold. And below that, we have occurrences of impacts, unsafe wells, farmers suffering from scarcity, women carrying water, rising costs, etc. And these would be the graphs that we need to have if we actually wanted to look at groundwater in a global perspective. But these graphs have never been prepared by anybody that I know, so I've just thrown them up here as a hypothesis. So such graphs based on actual data do not exist. And without the data, we're in a high state of uncertainty and jeopardy concerning water security, water insecurity, food insecurity, and health insecurity. Next slide. So this new documentary movie by Rockstrom with David Attenborough. So why is groundwater not mentioned? These are very smart people. Rockstrom is an internationally renowned scientist. Why is groundwater not mentioned? Next slide. And it's because his boundaries on which he's done his definitions don't include freshwater the way that I'm including it. Freshwater is embedded in chemical pollution, nitrogen cycle, biodiversity loss, etc. So Rockstrom defines his boundaries so that the freshwater problems are dispersed amongst his many 9 realms. And that doesn't mean that he didn't do a good job in what he was intending to do, but it doesn't help those of us who think groundwater is a problem and are trying to draw attention to it. I will be reaching out to Rockstrom, which I'm trying to do, to have a discussion about this. Next slide. So here's a summary slide. So we have evidence for our groundwater problem: land subsidence, seawater intrusion, soil salinization. We've got factors showing the trajectory towards a disaster, increasing population, overpumping. And we've got 10 reasons why our relationship with groundwater is a total mess. Slow groundwater response times, water's invisible, difficult to monitor, contamination is cumulative. We've got millions of waste release sites, fragmented regulations, externalized costs, globalization, unknown health impacts, and ignorance. Next slide. And the actions needed, we can slice and dice this in various ways, but I've done it here into 8 pieces. We need more groundwater education, firm commitments to safe drinking water. We need the circular economy, strict protection of groundwater, wells designed for safety. Many wells are unsafe because of the way they're designed. Aquitard protection. We need a systems approach to monitoring, and we need increased groundwater recharge or managed aquifer recharge. Next slide. So in our cradle-to-grave economic system, groundwater is the grave, and the alternative is a circular economy. It's referred to as the cradle-to-cradle economy. And more industries are going in that direction, so it's not just a pipe dream. Next slide. But agriculture is by far the biggest groundwater polluter. Nobody denies that. Next slide. And why is that? Well, agriculture uses 40% of the land surface, the entire planet, and our population is going to rise by 3 billion. Agriculture is responsible for 1/3 or more of greenhouse gas emissions. Okay, a little known number. So fixing agriculture is essential to fixing climate change and groundwater at the same time. Next slide. Now we have modern agriculture or agribusiness. We've got chemical agriculture on the left, and we've got ecological agriculture, which is a booming business. And in some European cities and parts of the United States, we have factory farming, layered farming. All of this is very ecological. All of it doesn't overuse water, and is the way that humanity is going to have to go, according to most people who look at this problem. Next slide. Now, the public has a fearful attitude to groundwater problems, and the relationship of the general public to groundwater is based mostly on emotions. Problems such as groundwater pollution put communities at risk, and the public is fearful. This makes science dialogue nearly impossible, so we need to have groundwater education for all. Next slide. Now, the United Nations certainly sees water as important, not groundwater, and prior to recently. And fresh water is embedded in 7 of the 17 United Nations Sustainability Development Goals. Next slide. And a resolution adopted by the United Nations General Assembly in 2010 recognizes the right to safe and clean drinking water as a human right essential for full enjoyment of life of all human beings. But when this was issued in 2010, since then, the number of human beings on the planet without this right is increasing, not decreasing, in spite of all of the efforts to try and correct this situation. Next slide. Now, according to Rockstrom, only 3 boundaries have already been transgressed: climate, biodiversity, and the nitrogen cycle. And his boundaries need to be reconfigured, and freshwater needs to be transgressed in his classification because groundwater is on such a bad trajectory. And this is all about what attention is groundwater going to get in the world and where is hydrogeology and groundwater science going to lead us. Next slide. Groundwater is invisible except at wells or springs, but these don't register as a tip of the iceberg. Next slide. And those bears are sitting there in the iceberg. They don't know why they're sitting there. They just know it's a good place to sit. Okay, that's kind of like we humans. We don't really realize what groundwater is doing for us. The general public is informed that we have a global problem of melting glaciers, but not a global groundwater problem. Next slide. But the United Nations now recognizes that groundwater matters. And so their theme for the 2022 World Water Day, which happens every 22nd of March, is groundwater making the invisible visible. So at last, groundwater is getting global recognition. Next slide. It is often stated that the cause of the groundwater mess is poor governance, but this is incorrect. Poor governance is a symptom and not a cause. Next slide. What is the root of the disastrous trajectory we were on? Ignorance about groundwater in all segments of society, and the solution to ignorance is education. And that's why the Groundwater Project is up and running and needs the attention and support from everybody who's interested in the world's freshwater crisis. Next slide. And if you go to the website, we've published 14 books, and we've got 5 more coming soon, and another 100 or 2 over the next few years. So there's lots to read if you want to read about groundwater written by excellent people across the globe. Next slide. And that's the end of my message, and I thank you for your attention. I'm really looking forward to discussion on this very important topic. Thank you.
Thank you very much, John. That was a very nice presentation. I'd like to introduce, I have the honor to introduce Dave Kreamer to you. Dave is a PhD professor of geoscience and past director of the Interdisciplinary Water Resources Management graduate program at the University of Nevada, Las Vegas. Dave serves as president of the International Association of Hydrogeologists, IAH, and is past IAH vice president for North America. They've also served as division director of the National Groundwater Association and is a past president of the university's Council on Water Resources. Dave's research includes work on water and international security, maintaining good water quality supply for people and ecosystems, particularly in economically developing regions, combating environmental contamination and water quality and quantity analysis and improvement. His current research includes groundwater contamination studies, groundwater-dependent ecosystem sustainability in U.S. national parks and public lands, and water supply in Africa. He has authored over 65 professional publications, recently co-authoring the 3rd edition of the textbook Contaminant Hydrogeologists, Waveland Press. He has given over 150 invited lectures. David has served as a professional consultant expert witness, has testified before the United States Congress and addressed the United Nations General Assembly. He also has given presentation at over 40 universities and has been an invited speaker in Europe, Asia, and the Caribbean, Pacific Island nations, South America, Africa, and Middle East. Again, the questions may be sent by our app, please download it, or directly on YouTube. This session has simultaneous translations into Portuguese on YouTube. Please make sure you direct your questions to one of our guests. Thank you, Dave, very much for coming again, for helping us on this struggle during this pandemic time, tough times for us, but we're being successful up to now. Thanks to your help and to all the hydrogeologists all over the world. Thank you. Welcome.
Thank you, Everton. I'm going to share my screen now, so it'll take just a moment here. everyone see that right now? Okay, great. My name's Dave Kramer, and thank you for that great introduction. It's always a challenge to follow John Cherry because we have 10 reasons why groundwater is messy, and John went through about maybe 30. And so when I prepare for this talk, what I'm looking at is a different slant. So what I hope to do in the next 15 minutes or so is give a different slant. I'll start off by just one slide explaining what the International Association of Hydrogeologists is. I'll do a brief review of some of the points John made, and maybe I'll make one or two new points in my 10 reasons why groundwater is a messy subject. So the International Association of Hydrogeologists has got over 4,000 members from 130 countries. It's been around since 1956, and it's a registered charity. And it's got a journal, the Hydrogeology Journal, which many of you know about. It's got 46 national chapters and growing around the world. We have regional vice presidents, and we also have commissions and networks to cover specific topics like groundwater and climate change, groundwater quality, karst hydrogeology, hard rock hydrogeology. We have an early career hydrogeology network, and many other groups. And it's a scientific and educational organization. And we're very proud to have the Congress in Brazil upcoming. It's just such a pleasure to join with the Brazilians in this effort. So what I'd like to do is review some of the dire needs for groundwater around the world. This picture is from northern Kenya, Turkana, where we put in some wells, and the situation is pretty bad there as far as water goes and getting water for people. And I want to review a couple of the things. I want to emphasize the inadequate sanitation that we have, and people are forced to live in situations where they need both sanitation and water from very limited areas. Very often the shallow groundwater is the widely used source of water, and there's inadequate protection sometimes of sanitation and waste disposal. In the picture you can see on the side here, we have a well that's very close to a pit privy that's going in. And that sort of a situation can cause problems, particularly in these COVID times. Groundwater supplies for rural communities and isolated communities, hand washing water. Although some of these situations can cause a center for spreading of disease and things like that, because many people go to these focused areas. John talked about industrial and agricultural pollution, and we have historical pollutants and emerging contaminants, including the poly and perfluoroalkyl substances, the PFAS. Here we have in the upper left-hand corner dumping in Phoenix, Arizona area, landfills. The middle picture is a well in South Africa. I don't think you'd want to drink from that well. It shows some mining in South Africa and in the North America, and mining waste are a potential problem. Pesticides being sprayed from the air and also from the ground. I think the ground shot is from Costa Rica. We have nuclear waste here, radioactive waste, low level and high level contamination problems. And then the one shot on the far right in the middle is actually coal tar seeping up out of the ground from an industrial facility in South Africa. The remediation technique for this is to wait till winter, till the coal tar becomes brittle, break it off and put it in a shed. So also the natural background was mentioned, which is important in many parts of the world. India and Bangladesh had severe arsenic problems, as you know. I've done a lot of work in the Grand Canyon, and I want to use this as an example. I studied springs, hundreds of springs in the Grand Canyon. We went and we gathered all the information we could on every single instance where water quality was measured at springs throughout the Grand Canyon. And it serves as an example for one of the problems with natural background contamination due to geologic sources. And the example I want to use, just one of many, is arsenic. When we looked at over 4,000 instances where water quality was measured, 87% of the time, arsenic was not even analyzed in the water sample. When it was analyzed, 11.6% of the time, we had non-detects. There was some detection of arsenic 88.4% of the time, and surprisingly, over half of the time, it was above the maximum contaminant level, which is the drinking water standard in the United States. 78 springs were above the MCL of 0.01 milligrams per liter. And so this points out that we don't know what a lot of the problems are around the world. So now I'd like to talk about 10 reasons groundwater is a mess. And I want to give a little bit different slant than we just heard, and maybe talk about some big issues and some specifics. Reason number one, I think we kind of miss some of the point when we don't say that a lot of the problems with climate change and agriculture and pollution is due to overpopulation. We have too many people on the planet. And this is really a socio-hydrogeology issue. Combined with that, we also have tremendous poverty problems in the world. And this is one factor that affects our groundwater mess. The fact that we continue to grow in population and we continue to pollute and utilize water. Certainly, water is associated with alleviation of poverty. This shot is from Botswana. And so the importance of water, and groundwater in particular, is very, very important in many parts of the world. Reason number two, I think that it's a mess, is because there's a lot of gender and age bias. And again, this is a socio-hydrogeology issue. The International Association of Hydrogeologists has a socio-hydrogeology network that addresses some of these things. By the way, you don't have to be a member of the International Association of Hydrogeologists to participate in our commissions and networks. Anyone can. But the idea is that in many parts of the world, children, and particularly young girls, have to carry water from long distances. This means that they don't get an education, and there are severe problems in the societal growth when you don't have equal education for all. Many children have to work in parts of the world. We also have a picture here of Dr. Alicia Oliveira from UNICEF. One of the problems in our field is that women and a diversity of people don't get a voice. In this particular session of the webinar, we don't have active participation of women, but the International Association of Hydrogeologists asks our congresses to include balance of gender. We make efforts to bring people from different parts of the world who might not be able to attend our congresses to that. But this is a problem throughout the world, that we have sort of a biased attitude toward groundwater. Another socio-hydrogeology effort that's really, really important is transboundary aquifer issues. John talked about future conflict and the potential for future conflict. And there are over 150 aquifers, major aquifers, that cross international boundaries, and many cross regional boundaries. And the idea is that we need to have agreements and decisions made as to how transboundary aquifer issues are going to be handled by different nations. Even though we have over 150 transboundary aquifers, there's only about 4 or 5 agreements in the world that are going forward. One is the Nubian sandstone aquifer that's shared between 4 countries in Africa. But we have a lot to do with agreements in transboundary aquifers. Okay, 1, 2, and 3, the socio-hydrogeologies, what can we do? One is advocacy. Many researchers in hydrogeology don't want to get involved in the advocacy for clean groundwater, gender equality, and involvement in transboundary aquifer agreements. But I think that this is one of the things that we need to do as hydrogeologists. One person told me at one time, why should we do this? It's a job of a politician or somebody who does issues with the compacts and the governments. But if we can't speak out on groundwater issues, really, who's better to do it than we are? The IAH has a burden groundwater network for international development that does global hydrophilanthropy. We also have a strategic overview series. And so part of this is education. The strategic overview series is a group of 4 to 6 page papers that are for decision makers and others that summarize different issues like groundwater and ecosystems, groundwater and climate change, groundwater and mining, for example. And so this strategic overview series is a summary of some things that are quickly used by staff of decision makers to help move the process forward. And then one thing else that we can do, many of us are from university backgrounds, we can do education. The upper left is a lecture in Zimbabwe. The upper right is a well course in South Africa. The lower left is Benin, and the bottom right is a lecture in Iraq to the water quality group there. So for socio-hydrology, in the words of a great philosopher, I would encourage everybody to speak. The great philosopher Homer Simpson said, if a tree falls in the forest, will you make a sound? and so I'm hoping that we'll be able to speak up as hydrogeologists in a hydrogeological community. Reason number 4, education. This was mentioned by John, but I want to take a little different slant on this. I think that one educational gap is the difference between what's taught in universities and the scientific and research advances and the way we're moving forward and the practice in the field. Field practitioners seem to not know a lot about the nuances and the new methodologies that go on. And there's a real education gap that's forming between what the science is doing and what field practitioners do. If I have one problem when I work in field situations is that a lot of people apply inappropriate information, inappropriate equations, inappropriate conceptual models to a groundwater problem. And I think one example is in a paper we just had come out in the future of groundwater science and research, the idea that Darcy is dead. Darcy is not really dead, but the idea is the assumptions of homogeneity and isotropy for aquifers is really giving way to a new paradigm that we have a lot of hard rock aquifers, fractured rock aquifers that really don't follow the basic equations that many people employ in the field. 5, hydrophilanthropy gone awry. There are thousands and thousands of groups trying to improve the human condition by going over and putting wells in foreign communities. And the problem is that some of these do-gooders make the problem worse. They have many errors that, and many of them come from not spending time with a local community before, during, and after a water problem. And the one backyard example, you can put in a perfectly good well in a community that really needs water. One of these hydrophilanthropy groups can go in and they can make it sustainable. They can construct the well perfectly, and the community really needs the water. But if you put it in the backyard of somebody who everybody hates, you've created a water war that might last generations. And so preliminary work with a community is essential. The sustainable hydrogeologic project progress can be thwarted in these examples by not consider regional norms, tradition, and power dynamics, the absence of a feasibility appraisal, and a lack of coordination with the community. And so reason number 6, inappropriate high-tech solutions. There's some estimates that put the number of inoperative wells that just don't do anything at about 1/3 of the wells in Africa. The idea is when a pump breaks down, the people can't fix it if it's a motorized pump or a solar pump or things of that sort. The pump will break and the well will be inoperative. I've seen many times people trudging by a well that's inoperative that they thought was going to be the solution to their problems. This low tech sometimes is the best tech. Here's a hand drilled well that's going in. This is in Kenya, and you can see this is a technology that other people could use. It's not high tech at all, but it's very, very transferable for shallow groundwater. This is one of my graduate students actually in northern Ghana. There's a distance there with a box between the pump and the outlet, and that is natural material that's filtering out arsenic. In this particular case, it's a natural low-tech solution to a groundwater problem in this area. So low-tech is sometimes the best tech. Conversely, reason number 7, we don't use enough the powerful new technologies that are around. The ones that I'm highlighting here have to do with satellite imagery. I have a large project in Niger that's going on now, and we're identifying shallow groundwater with some of these technologies. Many of you have heard the GRACE technology, the GRACE satellite technology that's been instrumental in understanding how groundwater is changing over large areas over a period of time. Also groundwater forensics, the idea of using chemicals to trace and track and date groundwater that's polluted is important technology. 8, data. Sean Cherry mentioned that data was really important. We need not only more transparency, not only more funding for important activity of gathering data in places, but we also need to harmonize data from around the world. There are a lot of different levels of groundwater that can be used. Sorry, from is spelled wrong there, but can we use more information from industry's deep surveys? The oil industry, for example, gathers all sorts of geologic information at depth, but if they don't find oil, very often they'll cover up a well and continue on looking for oil. There's a wealth of information that we can get there. 9, sometimes I think that we hydrogeologists have a lack of imagination about all the things we can do. For example, geothermal energy. Right now, the geothermal scientists can pretty much predict from a geological standpoint where a good place for geothermal energy is going to be, but the hydrogeology is fairly tricky and unknown. Geology, the hydrogeology of Mars. These are exciting areas of the future. And lastly, seabed hydrogeology. There are people working on fluid flow beneath the ocean floor, but I think it has important implications to everything from freshwater supply to climate change. The heat flux through the ocean floor may be a contributor to climate change. And the idea is we know very little about what the periodicity is of heat flow with fluids through the ocean floor. And so these are new future areas, and I would encourage all my hydrogeologist friends to look to the future of these exciting new possibilities for hydrogeologists. And so finally, number 10, the 10th reason that groundwater is a total mess is everything that John Cherry said. And so that's my final entry here. Thank you very much, and I look forward to a discussion.
Thank you very much, Dave, for your nice presentation. Great sense of humor as usual. Now I have the honor to introduce Ricardo Andrade. My friend, he's a civil engineer, graduated at the Federal University of Rio Grande do Norte, Brazil. Since 2017, he's director of the National Water and Sanitation Agency in Brazil. Today, he's an advisor to international relations at this agency. He just stepped out of his position as a director, right? He's also honorary governor at the World Water Council. He's the executive director of the 8th World Water Forum held in March 2018 in Brazil. More than 120,000 participants. That was huge, a huge achievement. Congratulations, Ricardo, great job. And as a former programs and projects implementation superintendent, he was responsible for groundwater studies and water conservation programs based on payment for environmental services and results-driven initiatives, such as the Water Producer Program and PRODES, River Basin Cleanup Program. Again, the questions may be sent by our app or directly on YouTube. This session has simultaneous translations into Portuguese on YouTube. Please make sure you direct your questions to one of our guests. Thank you, Ricardo. You're welcome. The word is yours now. Thank you. You have to unmute yourself.
Thank you, Everton. Thank you, International Association of Hydrologists. Thank you, Abbas, for the invitation. Imagine my challenge, Dave, after your presentation and the brilliant presentation that you both made. It's a very difficult task for me, but I will try to bring a different view of what was very wisely presented here today in this seminar. A big risk to be repetitive, but I will try. I will try to bring the Brazilian view and not the academic view, working view of the groundwater mess. I will divide my intervention in groups. The first theme that I would like to address is the governance. You guys already talked about that, but I think it's one of the most important points that we have to address. Lack of information on groundwater, technical information, gives a big, difficult task for regulators and users. Results on groundwater depletion, mining, exploring fossil water, saline intrusion. This is a big issue. We have a lack of professionals, limited regulatory capacity, few professionals involved on regulating the use of groundwater. Fiscalization is far from necessary. It's it's very difficult for state level institutions to do their work. In Brazil, we have a special legislation problem. It's very difficult. It's not a national rule. Groundwater is a role of state governance, and this is very difficult to keep to be far from a mess. It's really a mess on that. The other thing that I would like to address here is groundwater use. It's uncontrolled and unsafe well drilling is the biggest threat that we have, causing sanitary hazards among other several risks. It's very easy to drill a well, and so it's uncontrolled. Just a number, in Brazil, we have identified 2.6 million wells in our land, in our territory. Yes, 2.6 million wells. Only 330,000 are regular. It's on our database. A little bit more than 10% of our wells are registered. That is the number. And that is an open gate to contamination of aquifers. The most important thing that I would like to address, and I will try to keep my speech in 10 minutes to stimulate the debates. But the most important thing that I would like to bring to the floor is the involvement of citizens, education of youth, education of children's. Everton has a very nice project called Water Professor Agua, that tries to clarify water issues to normal citizens. Water user has to have social responsibilities also, and that is only possible if he is aware of the risks that we have approaching groundwater, especially, as already said by John and Dave with a lot of clarity. Communications at all levels, aiming to reach normal people. As I said during the 8th World Water Forum, we had to have a forum to address to people who drinks water. Technical professionals already know the risks, but normal people that drinks water is not always aware of the risks that they are causing on water issues. Not only the groundwater issues, the risk is bigger. It's slower, it's very more difficult to address a solution, but also the surface water. So I recommend, and I'm very pleased to know the groundwater project was introduced to the groundwater project recently, and I already volunteered to work on that and help as I can, to have an intensive communication, especially focused on children's and youth, as I already said. To finish, some final considerations, bringing to near our house on how we in Brazil try to face this big mess. groundwater is invisible. Yes, groundwater is invisible. Here at ANA, we work hard to consider surface and groundwater as one. Our decisions must take in consideration the link between groundwater and surface water. We use a hashtag, water is only one, água é uma só, to address that message. We cannot separate, and I was very happy to see on John Cherry's presentation that more than 50% of the basin flow of rivers comes from groundwater. We work on that for a long time, and now it seems that technical people are coming to face that thing. The other work that we do hard here is to build knowledge. We had important studies have been conducted by ANA with partners, metropolitan areas of major cities that depends on groundwater. We worked to build capacity, to build information, to build knowledge. And we are also working on important aquifers in Brazil, such as the transboundary aquifer of Guarani in the southern part of Brazil, and in the Amazon aquifer in the north of the country. We work, and it's a pleasure for me to be involved on that. As Everton mentioned, when I was lead on groundwater issues in ANA, we work side by side with ABAS on capacity building efforts, offering large number of courses to all public. And that is an issue that ABAS is continuing to do, and ANA is continuing to support. And we work also close to the state level governance bodies. As I said, in Brazil, groundwater is state role, is state responsibility. And we support our support to the state level is for strengthening institutional capacity, enhancing knowledge, and supporting regulatory actions. We need to conclude, Everton, and to keep my time strictly observed, we need to mobilize different levels of the society. We need to disseminate information related to the importance of groundwater and all risks associated with its use. We need empowered water users. It's not enough. We are not doing enough. We need to do more. And projects as a groundwater project led by you in Brazil and John in global environment is one of the ways that we must address and disseminate good information on groundwater use and risks associated with that. Thank you very much, and thank you, John, for John and David for the excellent presentation given to us, and I hope I can help on the following debates. Thank you very much, and congratulations.
Thank you very much, Ricardo. Always a joy having you with us. And thank you for your work on the World Water Council and in the Brazilian agency. Very good. You're always a friend of the groundwater people and doing good for the groundwater environment. Thank you very much. So guys, now we have, I'd like to thank you, the three of you, and we have some questions from the audience. Okay. I'm not gonna. I have some questions myself, but let's go for the people first. So the first question, I guess, is for Ricardo Andrade. Silvia Sala Setúbal. The indigenous community, Xerente, they stay downgradient of the hydropower Lajeado in the Tocantins, Brazil. What effects are observed on the groundwater down there, or in aquifers, downgradient of these dams? Would you have any information on that?
Not specifically on that region, but it's a very good information. But our professionals, our doctors can be more specific. But what we see when we have a dam, the nearby aquifers have the level gets higher. And sometimes is a problem. We had some issues in Belo Monte area, but in that Lajeado region, we don't have any register on that. In this is part of what I said. It's very difficult in Brazil because of this legislation. National Water Agency has no role on groundwater. It can be nonsense. It's a national water agency, and groundwater is not water for the National Water Agency. But we work together and very close with states to address some partnerships to study these problems. But we don't have any register of problems on that region.
Thank you. Now I have a question for John. John, it's Oscar Villalba. He's from Colombia. And he says, it's in Spanish, I'll translate. In which state is the world action about the water wellhead protection perimeters? And in Colombia, they're starting this politics now. I think Dave may add something if he likes. John. You have to, yeah.
Yep. Am I on?
You're on, yeah. Go ahead.
So that's a very key topic, wellhead protection and aquifer protection. And I haven't worked on it specifically, but what I've seen, it's an area of great confusion, and governments are prone to stake out areas that they want the public to know are protected. And one of the problems is there's so many different types of contaminants that can get in the ground in so many different ways. It's not really clear what a government agency should do if they actually wanted to engage in wellhead protection in a science-based way. There's lots of experience, but what I've seen, I mostly disagree with, and it's very contentious. So when people like me indicate to a local regulatory agency that's very proud of their wellhead protection, that maybe it doesn't make sense in many ways, then that's viewed as being against the greater good. And there needs to be, I think we need to gather up all the really good examples of how that's being done. And I mean, not to plug the Groundwater project too heavily here, but one of the things we want to do is we want to gather up the best examples around the world, so that any country that's interested in doing something would see where the best stuff is done. And the best stuff can be anywhere. It needn't be in North America or Europe. It's amazing where one finds the really good things happening.
All right, thank you. Dave, you want to add something?
Sure. I think this dovetails into what Ricardo was talking about illegal wells. So many people put in wells that are not known, they're not mapped. and the construction of these wells is sometimes very, very poor. In economically developing countries, there are sometimes many animals that come around the wells, and the animal droppings and things like that can flow right down the annular space of the wells if they're not properly constructed. And we don't really know in a lot of places what our water quality in our wells is. And so, there are a lot of challenges. There's, as John mentioned, all sorts of contaminants and from many sources. And it is one of the big challenges we have. Lastly, even if we have good well construction, good practices, good methodologies in place, and even good recording, the problem is enforcement in some countries is very, very poor of well measures and water quality promotion. And so we need to not only have the scientific part down and the engineering and construction part down, but we have to have the enforcement and regulatory capacity to protect wells.
Thank you. Thank you. I have another question here. That's more, this is one is more basic, I guess. Comes from Aquicultura IFC Morada Nova. Question is, what are the most relevant technologies we have to determine the volumes of our aquifers? Do we have any database available? That's very broad.
Dave, do you want to answer that?
Sure. When you go to a new area, one of the things you do with groundwater is you first have a conceptual model, and then you do what's known as a hydrogeologic framework model, which is a more or less quantification of the conceptual model, how much recharge you have, how much evaporation, rainfall. You look at well bores, geophysics to try and see the thickness of different aquifers, and it's on a case-by-case basis. We just finished one of these in southern Niger, and the challenge is to get all the available data to figure out what the properties of the aquifers are, what the storage capacity is, and what the overall travel times are. And sometimes this is difficult in countries where you don't have data, such as simple things like groundwater dating, to get an idea of the average residence time of groundwater in subsurface systems, to see how long it takes to recharge and things like that. So it's really a challenge. There is information for individual countries around the world.
Thank you. Thank you.
Everton, could I go back to an earlier question?
Yes, sure. You're welcome.
So, and follow up on I think what Dave was saying. So the issue of protecting wells, many wells are designed not to be as protective as they could be if you design the well in harmony with the geology and the hydrogeology, particularly in fractured rock. People talk about having a deep well in fractured rock and they think it's safe, but the casing only goes down a few tens of meters. And there's a lot of craziness that goes on. So in Canada, for example, if you want to renovate your house, you have to get a license. And the building inspector has to arrive, and the inspector has to improve all sorts of little things that you think you could do inside your own house. And I guess that's helpful for many people. And it means that when you sell your house, the next person who comes in is not going to have it fall down. But you can drill a well and nobody arrives to inspect it. Like nobody arrives to even see if the driller knew anything about filling out the records. I mean, it's a high level of societal insanity in a way, So governments feel obligated to protect us from our ignorance when it comes to building our house. And they don't care at all about the well being drilled. And you could say, well, the well is your problem, but then the house is your problem. But furthermore, small towns and small cities and whatnot that don't have the money to hire consultants and whatnot are drilling unsafe wells. And Ricardo, I'm sure, knows more about this than I do, the insanity of the system.
Yes, that's true. You want to say something, Ricardo, about that you mentioned?
No, it's a worldwide problem, and you sit transparent clarity. Groundwater is invisible. A house is growing up, the well is growing down. Nobody sees it. It's very difficult.
Mm-hmm. And I think the importance about finding out the examples, like, is there any country in the world that doesn't practice this type of insanity? And we have to find that country. Maybe there is some country out there that actually requires an inspector to inspect the design and inspect the ultimate. And if we can find that, then we can put it up in the bright lights so people like me can go to our governments in Canada and say, look at how backward we are. The problem with groundwater is we're having trouble finding these examples of lack of backwardness.
We have some experiences here in Brazil, as I said, more than it's a few number of wells in the range of 2.6 million.
Yeah.
But in some places we are better than in others. But we have to insist on building capacity, on giving good information,
yeah.
And I'm optimist.
Yeah.
Good. Guys, I have another question, and that I think is for Ricardo from Sergio Almeida. In the northeast region of Brazil, it is very common to have salinized water that are not proper for human and animal consumption. On top of the salinization, are there any other activities that could be boosted in the region?
We have, I'm from northeastern Brazil. I lived a lot of I'm now in Brasilia for quite a long time, but my professional skills came from Rio Grande do Norte, the heart of semi-arid region of Brazil. We have some solutions. We have some aqueducts that makes water flow from one river basin to another. We have desalination as possible. We have food production with salt water, especially to feed animals, with all risks that was already presented by John and David in salinating fields. But yes, we have some solutions, especially making, as we say in the northeastern Brazil, making the water walk, making the water run from one river basin to another. And the big experience in Brazil is the São Francisco river transfer or project, transposição do São Francisco, PISF. It's the big example that we have, Sergio, in the northeastern Brazil.
Thank you very much, Ricardo. Next question is from Cass Murray, and it's for Dave Kreamer. As a hydrogeologist from South Africa, how do we prevent the lack of baseline data at many of these sites being an excuse to not address an obvious mess?
The lack of data is pervasive throughout the world. I would want to assure the people from South Africa that it's not only their problem. If you go to polar regions, our frozen groundwater, permafrost, is a real problem. With the onslaught of climate change, it is a positive feedback loop. As permafrost melts, you get more organics, and it puts more methane into the atmosphere. Also, not to mention the Inuits who live in the Nunavut province have their tunnels that are traditionally used for refrigeration filling with meltwater and their houses sinking. So it's not only a South African problem, or it's a worldwide problem of lack of data. And how we harmonize it is really one of the biggest challenges. The United Nations is trying to gather information on water throughout the world. And one of the biggest obstacles that they've identified is getting groundwater data. So it's not only a problem with South Africa. Lastly, there are so many different databases from so many different sources, and they don't communicate with one another. And so sometimes trying to get data is very difficult. In some African countries, and other countries that I've visited, some of their old records are not electronic. They're in dusty old closets and paper records. And so it's a challenge. I don't think that there's a simple answer to that, but it's certainly something that we're working on, trying to get everything electronic and get it transparent and harmonized. I think Ricardo has something to say there. Did you raise your hand?
No. I fully agree with on what you said.
Okay.
Just that.
Okay, guys, thank you very much. We're reaching the end of our presentation here. I'd like you to make a final statement, very short, very brief. We have 1 minute more. Please, John, you first.
Oh, well, I think others have stated this, but getting all sorts of people in all sorts of walks of life, all the stakeholders involved in communicating, of course, is the key. Getting outside of the professional community and learning about what's going on in all the countries around the world. It's such an international problem.
Thank you. Dave?
There is a multiplicity of challenges for groundwater on all fronts and in all countries. I agree that we not only have to have stakeholders and politicians and decision makers, we have to have basic education, but even the hydrogeologic community ourselves. There are many practitioners that are unaware of things that can really mobilize their efforts and help their efforts. And lastly, proper regulation and government connection with groundwater is essential.
Thank you. Ricardo?
Everton, I can only say thank you for the lecture. Excellent presentation from John and David. For me, that I'm a professional, not a specialist on groundwater, was very nice to hear, to learn, and we have the same problem all over the world. I would like to emphasize the importance of the groundwater project, to seek for good practices all around the world. We have good practices in many places that can be used in other places.
Yeah.
I would like to bring the theme of the 8th World Water Forum, sharing water, sharing not only the good, but sharing good practices, sharing knowledge, sharing information. And that is the main message that I would like to bring. We need empowered citizen water users. That is I already said that to you later on. We have to change from rational to conscient use of water.
Thank you very much, Ricardo. Thank you very much for the three of you for the very nice presentation and participation. And for you who's watching this, you have to keep a message very clear from this session. More than talking about hydrogeology, we're bringing to you a cause. Groundwater is something that relates not only to ourselves who work with groundwater and are participating into this discussion. It is important to all citizens all over the world. So what is being brought here to you, it's a cause that has to go to every people. You, hydrogeologists, has to think on how you can bring this to lay people, people that don't know what groundwater is. We mentioned groundwater invisible, but it's our mission in the world as hydrogeologists to bring this to people that don't know why groundwater is so important for life on this planet. Okay, so with that, we come to an end of our session, 10 reasons why our relationship with groundwater is a total mess and what should be done. This is a part free online of our online programming of the Groundwater World Congress. Once again, I would like to thank the participation of John Cherry from the Groundwater Project, Dave Kreamer from the Hydrogeologists Association, and Ricardo Andrade from the ANA, National Water and Sanitation Agency. Thank you all from your audience. I hope that the content was useful to everyone that is here. Thank you. Follow Abbas, IAH, also on our social network. Download the app and participate in our WhatsApp groups, which warm up our presential event. Thank you very much and see you soon. Thank you, all of you. Bye, guys.